Alright, let's now check out the three random generators we get in Pigments. So they all three are identical, you just get three different variations on randomization. So let's start with the Turing generator. Alright, let's change up this basic tone here. I'll switch to more like a triangle shape. Maybe add a little bit of FM. Alright, so we have a slightly more harmonically rich sound. And now let's modulate the pitch of this oscillator with the Turing random generator. Now as I'm playing a note, you can already hear the result of this. And let's go ahead and quantize this. I'll make it to be the major scale. So even though this is random, the resulting modulation may sound a little less random because we're quantizing it to a particular scale. Actually, while we're doing this, let's also assign the same modulator to modulate the filter cutoff here. Alright, I'm also going to add some resonance to this filter. Alright, so how this random generator works is that you set the length of a sequence, and then it's going to just generate a random pattern for you. If I set this to just 1, it kind of just has two options. Either stay at the lowest value or jump up to the highest. But as I introduce more steps, it picks more random values in between. Let's add some reverb to the sound. Might sound a bit more interesting. Alright, now flip is interesting. When it's set in the center here at 50%, it's truly random. So those 13 steps we're introducing are completely randomized. But if I set the flip all the way down to 0, whatever last pattern the Turing generator was going to generate, it's just going to repeat that again and again. So now it's not really random. Well, the pattern is random, but it's repeating the same pattern again and again. But as I increase the flip, it starts to introduce some randomization. Some different notes in there. And then at 50%, it's completely random again. Now as we go higher, what happens is that the entire pattern starts to flip. So at 100%, whatever pattern it first creates, it then flips it. So let's say it's going downwards, and then it'll go upwards for the opposite version. Switching back to 0. Now we're stuck on one pattern, and it's going to repeat that. Rate you're familiar with already, just defining how fast the pattern should run. And then there's a reset source. This is also very familiar by now, hopefully. Alright, very cool. Next, let's check out sample and hold. This is more your classic random generator. So you choose a source here, and typically it's white noise. You can also choose any of the utility engine noises, so maybe the sampled noises. I'm going to leave it at white noise. And then you can define a trigger for when it samples that noise and generates a random value. Now here's the problem. As long as I'm holding a note, it will just stay on that note. Because when the trigger is the keyboard, you need to play a new note every time to generate a new random value. Now if you don't want that to happen, if you just want to hold a note and just make this generate a random pattern, you can choose a different trigger here. So if I click here, I can choose LFO1, let's say. And now when LFO1 crosses that 0 line, you can see how it triggers this sample and hold. Let's actually make LFO1 run a bit faster. And now I'm holding down a note. and the sample and hold is being triggered because of the LFO. There's a rise and fall, which is very cool. Right now it's very stepped. If I introduce some rise, you can hear the gliding effect there. So right now it's only gliding upwards, but if I introduce some fall, it'll glide downwards. You can lock this. So rise and fall are synced to the same value. Pretty interesting. And then lastly, there's binary. This doesn't quite work in this example because it only has two positions, either off or on. You can set the probability of getting off or on, or 0 or 1. So when it's all the way down, you're only going to get 0, and when it's all the way up, you're only going to get 1. In the center, there's equal probability of either 1 or 0. Then there's this correlation option. So the probability to stay on a current value, as I increase this, you notice that there's a higher chance for it to just stick to one particular value, and that introduces more gaps here. Rate we already know, and reset source we also already know. So in this scenario, not the best use for this. We could use maybe the sample and hold, and use random 3 as the trigger source, and we'll set random 3 to binary. So you notice whenever this jumps up to a positive value, we get a new trigger for the sample and hold. I can make that go faster. Alright, so lots of variety there for creating randomization in your sounds. Alright, in the next tutorial, we'll check out the combinate section.